Alright, good morning. How are we doing? Okay, so in our last class, this is where we actually stopped. I think after our last topic was on the feature selection, excluding identifiers, where I told us that it will be difficult for us, or it is not proper for us to pass a data to a predictive model with identifier. Remember, I said identifier in this case means the names of the name column here. These are unique value. They are called identifier. And at this point, what we did was to start with we pull them out from the entire data frame and store them as name in case we want to fall back to them. Then at this point we drop that particular column with the identifier, which is the name, and then we updated it again with our original data set that generated the whole of this. Now here we selected the age, the song, the PCT underscore pub as a subset of model underscore df. In other words, out of this data frame we brought out this, so which is part of data or feature selection. So here we apply a selection method that helps us to slice across three headers. That is, we pull out the age value and the song numbers value and the percentage of pop. That was what generated this. Then we have to save it as a valid data frame for us to make reference or to use it for our modeling. So here we save it. We took whatever that generated these three columns value and store it as model underscore subsets. So that is what we did here. Then here I gave you an assignment which happened to be our fifth assignment on feature selection. So I say, from Egwero Prosper, the lead data scientist, hi, we are almost ready for modeling. Just a few more steps. Can you save the student name column as its own series that we can use to reference later on? Can you create a final modeling data frame that include only the three new features? So this is supposed to be that we assign, that is video game, whatever. Then we are supposed to answer this question, this assignment. So this is an assignment I gave to you. So I believe you must have attended to that assignment. So now we are looking at another topic which is called scaling. Scaling is called scaling. So this, we are entering the deeper aspect of machine learning gradually. Scaling features. So we are done with feature selection. Now we are looking at scaling features. So what do we mean by scaling features? So the word scaling, as the name implies, requires setting all input features on a similar scale. Let me type it. Scaling, as the name implies, said it requires require setting all inputs. Require setting all input features. All input features on a similar scale. Now, just to emphasize on it, scaling is an optional feature. So what we are about to learn is actually an option, but in data modeling, it becomes essential when you want to probably engineer features. So scaling is an optional feature. Engineering steps which depends on the machine learning algorithm. So it's part of feature engineering steps. It's an optional, but it's a feature engineering steps which depends on the machine learning algorithm. So we have some common techniques for scaling, common techniques. So we look at some of them, some common techniques. Common techniques for scaling. Which include what we call normalization. And standardization. So when you are scaling your features, I want us to understand that the word feature here represents the headers. I think we have established that before, the header. For example, now, if I'm working with this data, age is a feature, songs is a feature, PCT_pool is also a feature. Now we are scaling them. That is what we are remeasuring them. We are revaluing them. So that is what we are doing, and there's a reason which we'll get to know. So why scaling is this important, even though it is an optional. It is an optional feature engineering step, but there are scenarios where it becomes necessary. Now, let's look at some tips. Many unsupervised learning techniques uses distance base. I think I need to write this for you. Notes. It's very important to understand this. That many unsupervised learning, all supervised learning techniques, many unsupervised learning techniques use distance. So this is going to be our standard or our criteria for scaling our data base. We are going to be scaling them based on how they are distanced from each other. Calculation, which makes scaling a required data preparation, before modeling. So we'll start with the first one. So that is an intro to what scaling features is all about. So the key word here is that there are two techniques we apply in scaling our data, which I have already mentioned: the normalization and standardization. So let's start with the first one, which is normalization. Let's quickly know what is called normalization in feature scaling. Normalization. What is normalization? So if we are to define normalization, we could say normalization transform. So you are normalizing it, probably something the data set is not good enough for your modeling, so you are effecting some changes, you are recalculating some values, that is, you are transforming the column to be. So your purpose for doing that is you have number which are not in between 0 and 1, or minus 1 and plus 1. So you are normalizing. In other words, you want to make it, transform all column to be between 0 and 1, or minus 1 and plus 1. So if you look at this, our data set now, let's see whether we really need to normalize it. So let's call back the subset data set, this last one. Let's see whether the values here, they are between 0 and 1. As you can see, they are not. Well, I just want to bring it closer. So if I run it, so not found. So let's run the entire notebook again, just to formally initialize all the codes. So the idea is that the data sets I am calling, or I'm about to display, is the data set we are going to use to practice or to implement the normalization and the standardization, which are both techniques in feature in scaling features. So you can see the values that we have here, they are not. We have 0.5, 0.2, 0.5. So these values, they are not within 0 and 1, or they are not even between negative 1 and positive 1. So that is why we want to normalize it in a way that at the end of the day we will end up rescaling these values so that they can range between 0 and 1, or between negative 1 and positive 1. So we're going to use this data. In other words, we are rescaling this data. And like I said, we have two techniques we use in scaling features. If you are not using normalization, where you transform all columns to be between 0 and 1, or negative 1 and positive 1, or we standardize them. But for now, we are focusing on normalization. So let's see how it goes. Now, there are some advanced Python libraries that we are going to involve here for us to be able to normalize. So it's not as if we are going to do a kind of manual calculation. So there are inbuilt libraries that are built in Python library that can actually help us to rescale this particular data. So now that we understand what it is, now we go straight to the application. Let's see how it goes. But I just feel that let me see, there's still more basic information I need to. So there is a library that we are going to use. So I think let me quickly highlight us about that. One of the key library that will be involved for us to be able to normalize this data, and that is sklearn. Sklearn, let me say, normalization with sklearn. So sklearn is one of the library we use in machine learning, so we are going to use it. Sklearn is a powerful sklearn is a powerful machine learning. So you see us using this particular library as we go forward from here. Powerful machine learning library that include a lot of machine learning algorithm, machine learning algorithm, and other techniques. So we are going to be using this library. I just want us to know what the library is. So it harbors a lot of functions which we are going to use to normalize this particular data. Okay, so let's quickly look at the application now. Now that we know what sklearn, just like the way you have pandas, the way you have numpy. So this is another Python library which comes with a lot of what algorithm or techniques which are used in machine learning, All right, so to start with, we are working with this data. So let me take it again. So we are going to start by importing the library. So we are working with this data. In other words, we want to scale this data features. And what are the features we have here? We have just age, we have just song and PC, just 3 features. We want to scale them so that at the end of our scaling, we should be able to see that all the values here ranges between 0 and 1, or -1 to +1. So the first thing we are going to do, we are going to import. So let me use comment. Import this library. Import sklearn. Now anywhere I use capital letter, you have to observe it. They are case sensitive, this library. Import sklearn dot processing. dot pre-processing, so let's see here, let me just make it import sklearn library. Let me just stop here like this. So I will say from, so this is live code now, from sklearn dot pre-processing imports. So that is the module where you are importing this from. You are saying that from this particular library imports mini mass. So the M is in capital letter, mini mass. Like I told us, follow the case here, scalar, because we are scaling. So this is just like a pieces of function which we need to get the minimum. Remember, we are scaling from 0 to 1 to get the minimum, and that value, that particular function, is drawn from here. So from this container we are pulling out this because we need this to get the minimum. So I will execute that to see if I have been able to import that before I proceed with my code. So I need to initialize to be sure that we have sklearn imported successfully. Good. So you can see the time it took because it's a bit heavier than other ones we have been working with. So a whole bunch of algorithm, techniques, functions are in that sklearn. Now the next thing I'm going to do is to store the mini scalar in a variable that I can be referencing. So I will just say mm, can actually be any name, but I'm using name that rhyme with what we are doing, equals to the mini mass scalar. That is, there are two things we are bringing here. One is going to help us to calculate the minimum under each column, and then the other one is going to help us to calculate the maximum. So we are bringing two of them at the center. That's why they are together as mini mass. So it's a function this time around. So we are storing the whole of this function inside this variable. So I will execute it to see if I'm good there. So it's not found. It's not found. I think I'm wrong with my spelling. Instead of min, I use what? Mini. So let me run it again. Good. So that is good now. So the next thing is for me to do the transformation. So I want to use these functions that I have imported. Remember that at the moment our mini mass scalar as the function that will help us to calculate the minimum and the maximum under each column is already stored in this variable. So I could just, if I want to transform my data now, this particular data now, so what I am going to do is to take this variable name, which is the mini and mass underscore scalar. So I will just copy it, make my work faster, paste it. Then I will concatenate it with what? This fit. So this fit is another function that we are accessing from the sklearn. Remember I told that what sklearn contain a lot of algorithm and techniques which we use in machine learning. So we are just accessing these functions one after the other based on what we want to do. And when I was defining, I said in normalization we transform the data so that the values under the features can range from 0 to 1 or minus 1 to 1. So we need all these pieces of functions, like the way we got that minimal scalar from the sklearn preprocessing. that we are getting this fit, which is a transformative function. Now it's a function, so inside it we pass in our data. So we are going to pass the data, is going to transform. So Control C. So I'm passing in the data, paste it inside, and then I will run it. So this fit function is a transformer, so it's going to transform this data. It's going to scale. Remember that it's going to scale it in a way that we'll be able to get the minimum under each column and the maximum under each column. That is the expression, what you are typically saying. Remember that we have stored the two functions that will calculate the minimum under the features under this here, and they are stored here. That is why we are concatenating the function to this. So at this point, the minimum and maximum scalar is being attached to a function that is going to transform the data. So what this will do is that for each value it subtracts the minimum of that column and divide it by the maximum of that same column. So here now it will subtract the minimum of this column and the maximum of this column. Sorry, it will subtract each value. It will subtract, as for each value, it subtracts the minimum of that column and divide it by the maximum. So that is what it's going to do for us. So let's run it and see if we have it. Good. So applied. So for us to output this, it means that that particular scaling has taken place. That particular scaling has taken place. So like I said, what have just happened in expression, if we are to explain what happened here now, we can say it will, and that is what happened, or it calculates the minimum and maximum. It calculates the minimum and maximum. The minimum and maximum of the column. That is the features. That is what happened here now. So if we want to confirm this, if I want to view only the minimum value to see the calculation that actually took place, so I will write to view the minimum, or to view the data minimum. I will use the syntax. So the syntax will be, I'll call the underscore scalar, underscore scalar. I'll say dot data underscore min is a function, then underscore. So if I run this, it will show me the list of the minimum under each of the column. You see that if you are here to show you let's say what we have here now, let's look at it. The array, there are 3 columns there. We have column what? We have column H. Under column H, the minimum is 19. That is what you have here. Under column number of song, the minimum is 2. That is what you have here. Then under column percentage of pop or pop, we have the minimum as 0. So this is to tell you that we have implemented this function, have actually rescaled, or this function have calculated the minimum and the maximum in each column. So now let's also check to So to view, if I want to see, to view the maximum as well, just like the way we just viewed the minimum under each column, I want to view the maximum under each column. So what do? I'll do the same thing, as my variable name, underscore scalar, then dots data, then underscore mass underscore. Then if I run it, it will generate the mass under each column. So which means that in age, the maximum value is 52. In number of songs, the maximum value is, let's check what we got, is 121. And then the maximum value under P percentage of Pope is this. So with this, we are guaranteed that we have been able to calculate the minimum and the maximum under each of the features, so we can always pull them out if the case arises. Okay, so now to apply the transformation, now that we have been able to sort out the issue of minimum, remember our objective is at the end, all the value, this value that we just call out their minimum and maximum now, will be rescaled in a way that the value we have there will range between 0 to 1. So what we are trying to do is to calculate the minimum and the maximums first before we transform them to become 0 to 1. So now to apply the transformation, now to apply the transformation, we will simply call that variable underscore scalar dot, we are picking another function now from that sklen, transform. What are we transforming? The data we gave, the one we just sort out, its minimum and maximum now, which is subset. And then if I run it, so we have been able to transform it. So you can see that all the values I have under the three header, this value you are seeing here represents the age. So now we have reconfigured, we have rescaled the age to what? 0 points. Remember, we are going to what? 0 points. That is 0 number that ranges from 0 to 1. So we have transformed everything. You can see that everything is now between the range of 0 point, 0 point, 0 point, 0 point, 1 point, 1 point. So that is the power of this. The transformer is what, the configure is what is actually doing the scaling. Where we use fit is just for us to get the minimum and the maximum in each column. So the idea is that we are trying to prepare this data in a way that it can easily be passed into predictive analysis model. So that is the whole essence of what we are doing. So there will be an observation here. What is the observation? Observation. Our observation here, we now have only values from 0 and 1, which is our objective. Okay, now we can now add, let's assemble all the code, because we are running them individually, because I have to go through this so that you understand what is doing what on each line. So now that we have confirmed them, let's quickly assemble them in one cell so that the code will not be scattered. So in one cell, what we'll simply do, so let me use comments so I understand what I'm doing here. Finally assemble all the code in one cell. And what that will do is to enable us or you assign the results to a data frame that you will now be using for your modeling. To a data frame. So doing that, I'll quickly say from sklen. So I don't want to waste my time. So let me go to, because I've written it somewhere. So let me just copy the whole of this line, Ctrl C. That was the first line. Then after this, the next one was where we store the minimal scalar in a variable called this. So I'll take this also, Ctrl C. I paste. The next line is where we are now assigning it to a data frame. So we just call it normalize, because that is the method we are using now. Normalize is equals to, so this is the reason why we are assigning. So we will assign our first transformation, which is this, where we calculated the minimum and the maximum. So I'm taking this and I'm assigning it to normalize, or let me type it, because I added it to the other one at once. So I have that is minimum and maximum scalar dot fit as a function, fit underscore transform, and then inside this I'm supplying my data set model underscore subset. I'm correct with that, subset. Then in my next line I'll say PD, because I want to convert it to a data frame. PD data frame. So I'm supplying my variable, which is this. Ctrl C. Then I'm bringing it here. Normalize. What are we normalizing in this data that will have been the minimum and maximum and the transformation will have been applied? The columns. The columns is what we remember. The columns is an attribute, so equals to. Then we'll now supply the name of the data set again, underscore subset. Then dot columns. Alright, so here we have assembled all the code. So this is how I will have written them in the first place. But if I bring all of them at once, it might confuse you. So we have to break them down. Now you know what this line did. This is where we imported the main library that is offering us all these sub functions we are using to scale our feature. This is where we store it. Now that we have imported it, this is where we store it in a variable, so that each time we need it, we just call the variable. This is where we are normalizing. So I'm taking the whole of that variable and I am adding it to this transformer, and then pass in the name of the data I'm transforming. So a result will have been generated here. Now we want to put it in a data frame, so we bring in pandas.data frame just to make it look proper. So now you can see as soon as you run, you have it in a data frame, because the one you outputted before here, it was not carrying the header, so we cannot store this as data frame, and that is why we have to use PD using this function to frame it to look like a real data set that we can pass into our model. So as you are seeing this here, is better, it's looking more presentable, it's looking more real. So this is now in a data frame. So you have transformed and you have represented it as a data frame. And if you look at this, we have actually achieved our aim. There's no value here that is greater than 0, that is greater than what? 1. Between 0 and 1. So if we want to find out, if you want, there's a note here in case you want to do further verification. So if you want to check, if we have actually normalized. If it's normalized, there's a way we will check now. It's normalized, we are saying it, but we just want to describe it. It's one of the commands we have already known. Normalize. If we want to check whether it's normalized, so we can just copy the whole of this code. Ctrl C. Then I will just add .describe. It's part of what we have learned under data analysis. Describe. So we want to check those minimum. Describe usually give us minimum, maximum. So let's say describe. So I'm just concatenating this to run it. So to describe it, so you can see that count, we have 8 of them. Check your minimum and then check your maximum. You can see all the maximum are between 1, all the minimum are between 0. So with this, you have achieved. So this is one way you can check if you have actually normalized your data. Now you can see minimum and maximum values are between. So let me use notes to put that for you. Now you can see minimum, maximum values are between 0 and 1. So that is how you can use sklearn for normalization. That is how you can use sklearn for normalization. Alright, so remember I said there are 2 techniques we use. One is normalization, one is what? Standardization. When I started at the beginning, I said for us to be able to scale our features to machine learning algorithm or techniques are involved. Normalization and standardization, and the aim is to to make sure that all our values ranges between 0 and 1. So with normalization method we have achieved it. So let's quickly look at with the standardization method. Let's see what we get. So now we are looking at standardization method of scaling features. So I believe everything we have done so far is clear to you. We are focusing on this now. So we are going to start with what is standardization. So standardization, let me see if I can actually finish it. Standardization transforms all column to have a mean of 0 and standard deviation of 1. Standard deviation of 1. Just a minute. So, what is a standard deviation? Standard deviation is a statistical measure that represents the amount of variations or dispersion in a set of data. Let me see if I can put it in right, because we need to understand what standard deviation, because that is the method we are using in this case. It's a note standard, let me say STD, so you understand. STD is a statistical measure that represents the amount of variation, as the differences, the amount of variation or dispersion in a set of data. That's the meaning of standard deviation, because that is the method or the techniques the standardization scaling adopts. So we need to understand how it works. All right, now just to add more note to it, this is typically used when typically used when the column distribution, when the column distributions are normal. So what that means, for us to know that they are normal, the shape the data will form, like in a graph, will be like a bell curve, like a bell curve. So in other word, the distributions of data, distribution of data in each, so I'm trying to explain that curve, in each column shape is like a bell curve. Go to see that in a moment, don't worry. So that is how will we know if the data is normal. So just to add more notes, trying to give you a strong background about what standardization is. The main reason, or the reason for this is because that is like the reason is that standard deviation, or let's say mean and STD, is most applicable to data bell curve shape. Okay, so now let's quickly look at the application. So I'll just trying to give us a background of what this method is all about. So in our first cell, let's also import our library, which is so to start with, import your library. Very important, import your library. So we are still working with the sklen. So from sklen, you can see this sklen is widely used. From sklen dot that same pre-processing import. Remember, you have to watch out for the KC also. The S is capital letter. Now we are importing this sub from that sklen standard scalar, not minimums now, scalar. So this is what we are getting from there. So let me run it and see. No module name was sklen. So there's a mistake here. Sklen. Okay, good. So we have successfully imported what we need to standardize this data. Remember, when we were using the normalization, what we use, the functions, we involve the same library, but what we brought out from that library was different. We brought out so what you brought out so what you actually brought out was minimal scalar, but in this case what we are bringing out is standard scalar because we are standardizing. So this is just like an alternative method of scaling your feature. Is either you use the normalization. If you are more comfortable with this one that I use, fine. But if you are more comfortable with this, you have to work with different set of sub functions under the same main library. So the idea is, as a machine learning, as a data scientist, you need to be aware of all these tools. So what we are trying to do is to expose you to different functions, different library. If not for machine learning, I'm not sure that you have once used or know what is called sklearn. What you were using mostly for your just data analysis was pandas, numpy. So the more you go into machine learning, then the more core libraries and their sub functions you involve, and that is what is happening here now. So we have been able to import that. We are still going to assemble everything later, but let's understand them individually first. So the next one is that I will just create a variable called what? std scalar, just like we did the other time. std, that is standard deviation scalar. So equals to, so I'm storing that standard. I'm storing the standard scalar inside it. I'm storing the standard scalar inside it as a function. So let me confirm that. Confirm. So now this is a variable. So you are storing this sub function which you have already imported from what? Your main library. So that anytime I want to use it, I will just call the what? The variable name. So the next thing I'm going to do, I'm going to call that std underscore scalar, which is the variable that I just created now. And then I will now add it to the fits. Remember, so we are concatenating now. We are adding this sub function, which is dot fit, in order to transform the data, to standardize the data. So I will open a bracket, then I will supply the name of my data, which is still model underscore subset. Model underscore subset. So if I run it, just like what we did, so you have successfully standardized it. So now let's interpret the result. What is it saying? So the result, this result now, so now we have been able to calculate, let's say what now we have been able to calculate the mean. Remember that this standardization uses mean and standard deviation. So mean and standard deviation of each, just like what we did the other time, of each column. That is what we have done now, of each column of my data set. Each column of my data set. So if we want to check the mean, just like the way we check for the maximum and minimum the other time, after we have transformed or we calculated that. So now to check, now to check for mean. Let's check for mean first. Now to check for mean, so we simply say std, which is the variable that we created, underscore scalar dot mean, then underscore. If you run this, it's going to bring out the mean of each column. So if we go back to the data set now, you know how mean, just like you know how mean is calculated. It will add, mean is like your average here now. You add all the value divided by the number of value there. That will give you, for each column, if you add all the value there, you add all the values you have here, add all of them together, divide by the number of, entry, it will give you that for each column. We have 3 columns in the data set we are working with, so that is what we have here now. So the standardization uses the mean and the standard deviation, which I have to define what standard deviation is before we started this. Remember I said, standard deviation is a statistical measure that represents the amount of variation, how things are different from each other. What's the degrees of what deviation? How is one different from, how is one entity deviating from other? What is the degree of the differences? That is what standard deviation focuses on. Okay, so to check for variance, let's see how. Since we check for to check for variance, which is related to standard deviation, because standard deviation is just a square root, of a variance. We have taught some of these things in school. Square of variance is a standard deviation. Variance. So if you want to check for it, so I'll simply say std underscore scalar as my variable, underscore scalar dot variance, which I said is related just square root of standard deviation, underscore. So if I run it, so you can see it. So remember, the idea is 0 to 1. But we are using mean and standard deviation concept here because this is standardization. So we have been able to verify that our fits have actually done the mean and the standard deviation calculation. So if we want to now want to run the script, we want to describe just like the way we did it the other time so that we know, then to describe, these are just measures of verification. To describe in order to check for the mean, and because describe always give us this analysis, and STD, standard deviation. So what we'll simply do is to run this code to check, So I'll just say model underscore subset dot describe then I will just run it. So if you want to check, you can see when we run it for mean, look at the value we get, 32.77. Now as you describe that data, now you can see truly. Now when we run it for the variance, what do they get? We have this value 1 point. So let's check for standard deviation here. What we have here, standard deviation, we have 11, but remember that calculation has been done there. That is divided by the number. That is why it's still showing here. But at least we have been able to what? To check for this. Alright, so now we have calculated. Now that we have calculated, let's transform. Remember, at the end of each calculation, you transform. Now let me use comments. Now we have calculated. Let us transform. Let us transform. Let us transform the data. Right? So our code will now be the variable std underscore scalar dot transform. It's a function from that scalar model. What is it? Transform is supply your data set subset. So if we run it, it will give us an array scalar, standard scalar object has no attribute, transform. Oh, my spelling is wrong. So good. So this is the same, almost the same process. So you can see that now that we have transformed, we now have value ranging between 0 and 1, just like we did with the other method, which is normalization. Remember, we use the fit first before we use the transform. Then we now convert it to data frame so that we can have all the header listed alongside with the transform value. So good. If you check this column now, there is no value that is greater than 1 or negative 1 or even 0. So they are all within, which is our main essence. What we define feature scaling or scaling features to be. Let me just draw your attention back so that you know our objective from the beginning. I say scaling, as the name implies, requires setting all input features, the value under each of the headings, on a similar scale. Some common techniques for scaling include this, and then there is a place where I said so that the value will be within 0 and 1. I think I only read it. I did not. Okay, yes. Normalization transform all columns to be between. Okay, so now let's move on. So we have enabled, so we're on the way very soon. Now, what is our observation? Observation is that now every column has a mean of 0. That is what I observed there. If you look at that value or the values before us, now every column has a mean of 0 and standard deviation. Standard deviation 1. That is what we have here now. Alright, now to apply the shortcuts, there's a way you can actually do this using a single line. So all you need to do, let me just use comment to apply shortcuts. Syntax will be std scalar dot fit underscore, just like what we did the other time. Transform, just like you are combining two of them at once. Transform, open your bracket, supply your data, model underscore sub set. If I run this, you see it's still the same thing as you writing it like this. So here you have, here the calculation was done and the transformation was also done at the same time. Now we can assemble all the code in one place so that we can assign them to data's frame, just like we did the other time. Now let's assemble all the code in one cell to enable us assign the results to a data frame. Alright, so to assemble, let's go and copy and paste. We don't need to start writing all the code from scratch. So we need this. I'll take this first. Control C, paste it here as the first line. So the second line is where we store the scalar in the variable. Where is it? Here. I'm taking this also. So copy and paste because we are waiting them. So the next one is where we want to standardize. We want to create a variable, standardize. Standardize is equals to let me just take this one, this shortcut. Standardize, because that is the level at which you standardize the data. Then we will now do PD. Now we are converting into data frame so that we can have our headings alongside with the transform values. So we will frame them using data frame so we are supplying this. That's where we have our results. We are giving it to this to frame for us. Then comma, we want to add column, we want to define our column. We want it to define column equals to model, which data are you displaying the column? Model sub set dot columns. So if I run this, then I have my value in a proper form. So that is to bring us to the end of scaling feature. So let's assume what to check for mean and standard deviation from the result we just produced now. To check just like we did the other time, to check for mean, because we have a transform. You know, where we checked the other time, the deviation was not good because then we have not transformed. Now we want to see mean and STD. So I will just add describe to this my data frame. So I will just add dot describe here also and run it. So you can see this is your mean between this, your mean, and then you have your STD. You can see it between one, all the value. So with this we are good to go. Now, but I want us to know that there's one more thing we need to do. If I call model, let's see if it has updated, or we have to receive it in a variable. Model subset. If I say subset, we need to also do that for the other one. So you can see that it's still calling what? The original data. So which means that we are supposed to update it. We are supposed to reassign it. Or maybe use another one. You can say final underscore model underscore data, the one that is ready for. So you can now display it. So now, as you have, because this is the one you are going to send for you are going to use for your predictive analysis. So if I say C, just to display it, just to see. So I'm not interested in describing it. So let me just remove this. Okay, so I have it as my valid data now. Okay, so this is my valid data. So let me take off this. Don't need it. So we ought to have done the same thing to the other one. We take it and store it in the valid data. This one here. This one. This one. So we can say what can I use here? Let's say that one will have a final results. Let me just to differentiate it from the other one. Results data equals to, and I run again. So all right, so now we have assignments. We have assignment here, but time will not permit us. So this is supposed to be our assignment 6. So let me read out the assignment, or let me write it. Maybe in our next class we will solve that. We'll solve the assignment so to enable us to understand this concept better. So what is the assignment? Greeting from Egwero. From use comment because from is a keyword. From Egwero Prosper, who happen to be your lead data scientist, who happen to be your data scientist. Subject of the assignment is features scaling. Requests. The body of the message is hi. I have one final request for you. Success. We plan on clustering, so that will be our next topic. So we are planning on clustering. The data using a distance based algorithm. So the data needs to be scaled. Using the data frame with the three features. Using the three features for modeling. Modeling can you scale the column? Can you scale the column so that they all have a mean of 0, and a standard deviation of 1, once you do that command, we should be all set with our data prep steps and ready for modeling. So all these things is for you to make data ready for modeling, which I said falls under data cleaning preparation in machine learning. So just want to thank you, because I know you are going to do it. For help this week. Okay, so just to give you some hints. Assignment, key objective, so that this will have a way of guiding you. Key objectives. Assignment key objective number 1. Scale the feature. Scale the features in the model data frame, so they all have a mean of 0 and a standard. Deviation of 1. Then hit 2. Save the output. Save the output as a final. Save the output as a final data frame. Save the output as a final data frame. It is ready for modeling. So in our next meeting, we look at, we'll start by viewing the assignment solution. Assignment 6 solution. Then after that, before we look at clustering. Alright, so I believe you find this class interesting. So take your time to implement all that I've explained, including the assignments if you can attempt. But definitely in our next meeting, I will start by answering or giving us the solution of that assignment. So once we are done with that, we will now move into clustering, which is another topic where we shall also be introduced to different libraries. So in all, today we introduce new library like sklearn, and inside sklearn we were able to abstract sub-functions like minimas, scalar, fit, transform. Then you saw what we achieved with them. So we are stopping here. See you in the next class. Bye for now.